Can you see everyone waving to you? We would like to get on with this next very exciting portion of the Lunar Science Forum. We are so pleased to have John Grunsfeld, the Associate Administrator for the Science Mission Directorate, and Bill Gerstenmaier, the Associate Administrator for the Human Exploration and Operations Mission Directorate, with us today to talk about this new era of enhanced collaboration between science and exploration. John and Bill, thank you so much for joining us. I'm going to let you take it away, and then we'll open it up for questions. Audience, we do have microphones that we want to reach you before you start asking your questions after the speakers have finished. Thank you.
John, you go first. So I'm the all right. We see a blue screen, and that always is an interesting IT problem. There we go. All right, well, I'm glad to see everybody sitting in the front row. That's always a good sign. So being the new kid on the block, relatively speaking, I've been in the job about 6 months, but I can tell you that from day one of my goals was to try and enhance further collaboration between the human exploration and operations part of NASA and the science part. I think all of you know that my heritage with NASA is an almost 20-year career, most of it was spent as an astronaut. But through the luck of the draw or some grand design, as a physicist, most of the mission work that I did had a science component. Well, if you call the Hubble Space Telescope a science component, which obviously I do. So I'm really excited to be back in this leadership position and to be able to work with Bill Gerstenmaier to try and bring the goals of science and exploration and using those tools to go out and explore the cosmos. The reason why I'm emphasizing this in my short opening remarks is that's what the Lunar Science Institute was all about. I was a participant with one of the teams, one of the University of Colorado teams, before I came back to NASA, and it's very exciting. I think it's been very effective to have the institute. I have the three-year science report, three-year report right here, and we're looking forward to a more expanded role as NASA has increased our scope from a lunar-centric exploration program to one that includes other destinations out in the solar system. And I like to say we live in a solar system of riches, but there's actually only a few places in the near term that we can go as people. And so we're investigating near-Earth asteroids and Mars in a lot more detail. Mars has been on our list, I think, much longer than there's been a NASA, and certainly the entire history of NASA in one form or another we have Mars as a destination. And so I hope that you all have the opportunity in 17 days to help us celebrate the landing of the Curiosity rover as part of the Mars Science Laboratory. And probably, some of you, if not many of you, have some involvement with that mission or with the science that will come out of it. With that, I'd like to turn it over to Bill Gerstenmaier.
Thanks, John, and I'd just amplify a little bit on what John said, that I think by our two directors, we working close together, we can really achieve a lot more than any one of us individually as directors or leaders of our organizations. And the Lunar Science Institute has really been a great forum for both of us to work together. Both directors worked together even before John came. You know, we were jointly funded by us. We were moving forward. The Lunar Reconnaissance Orbiter has been, you know, a very nice piece of hardware for us on the exploration side when that was our focus to look at the moon. We were gaining really interesting data there that we needed for us to find landing sites and look for other areas and areas we want to go look at and really get a different look at the moon than we've had before. And then what's intriguing is the science team then kind of picked up on that, and they've actually leveraged off of some of the data we've got there, and it's been really important to a broader community than just the exploration folks, what's going on with LRO. It also turns out the international community is interested in that same information, so it has pretty broad implications. And then GRAIL comes along, which is kind of the science mission director at you know, spacecraft, and looking again at the gravity and recovery and interior laboratory mission kind of things. And then I look at that from an exploration standpoint, and if we're going to do some things, understanding that detailed gravity map, especially on the dark side, are really important to the future of us and where we're going forward, and especially to the international community as they talk about some robotic missions. The data provided by LRO and by GRAIL, the combination of those are going to be tremendously important data to inform them of what they're doing. So, you know, I think John and I will continue to have a strong relationship working together. We're working on the Mars planning group activity together that John's leading and I'm supporting. There's lots of synergies between both organizations. We'll continue that strong focus moving forward.
So to that end, you know, we've had a very successful run with the NASA Lunar Science Institute, and so we're in the process of working the cooperative agreement notice with the Institute to actually expand its role. So it will, we're still working on the naming and through the legal process of getting this all to happen, but we are going to put out a community announcement that will, and so you're the first group to hear this, which is appropriate since it's your team, that both the Human Exploration Directorate and the NASA Science Directorate jointly are going to expand the role of content beyond the moon. So we're going to leave, the Earth-Moon system to include other bodies in the solar system, near-Earth asteroids, and the planet Mars. And so I think this is very exciting because there's a lot of synergy. We now can talk for the very first time in the past couple of years about volatiles on the moon as a credible science topic. And of course, we have volatiles in comets. We may have volatiles in near-Earth asteroids or near-Earth objects. And we know now from Mars Reconnaissance Orbiter observations that we have volatiles on Mars outside of the polar caps with these briny flows that we see in gullies on Mars. And so this is an opportunity to leverage the interdisciplinary nature of the Lunar Science Institute to these other areas where we will be exploring in the coming decades.
And when this cooperative our community announcement comes out, we'll put it out in a draft form, and you guys will get a chance to critique it and edit it a little bit, and then we'll work on it, put a final one out, and then seek proposals later. And again, as John said, this is a little early. You'll probably be seeing this in the next couple of days as it actually comes out in its first release form. But we wanted to let you guys know ahead of where we're heading with this, and I think it's a pretty exciting way to look at these as really a broader scope of destinations for humans and science, really throughout the solar system. So with that, maybe we can answer any questions you got or dialogue with you a little bit.
Great. Well, thank you so much, and thank you for making that announcement. Let's give them a round of applause. As you guys can imagine, this comes as a great pleasure to those of us here in the Lunar Science Institute who have been looking forward to announcing this expansion and talking to this community about it with some detail. So I'm sure they have questions, and I would like you to raise your hands now, and we will try and reach everybody in the time that we have. We have a good amount of time left, so there's one right there.
Hi, John. This is John Cooper. What are you going to call this thing? Princess needs a name. What's the name?
So we've spent a fair amount of time talking about that, and hi, John. And we don't have a name yet because in the end, when you announce things like this, one name may sound great to a small group of people, and then somebody in legal points out that well, that's a trademark, or that is in Portuguese is a swear word, or who knows. So actually, I'll go out on a limb here and say that I suggested to the team this morning that perhaps we should open up the naming to all of you folks and the community, and see what you come up with. So we'll probably, maybe almost certainly, I'm looking at Mike Wargo from Human Spaceflight. We may put out the community announcement announcing the content, and then somewhat simultaneously open up a web page as a naming contest.
Yep. Sounds good.
So.
That sounds like a great idea to me. Another question? Okay. Pam.
Because there are important things that have to be done to prepare instrumentation and technologies to go to any planetary surfaces and survive there for lengthy periods of time without necessarily having access to radiothermal generators, particularly. What role do you see the new institute playing in supporting the development of supporting technologies and instrumentation?
Well, I think that's an important role that you've already even played for the lunar effort, and an expanded role. And there are many different levels of that, but we are working on advanced radioactive thermal generators for deep space missions, and that would include for science missions and technology missions on planetary surfaces or deep space. That's a much broader question, but there's technology development, and then there's also sort of the public outreach aspect that when we get to nuclear, it's often something that people think, oh, we don't want to put nuclear in space, forgetting the fact that the sun is a fusion-powered star, and has these huge coronal mass ejections of plasma. But we also have to help educate and do outreach to let people know that these power supplies, allow us to do science we couldn't otherwise do.
I hear you, except that it isn't really, this is not really a dangerous nuclear issue. It's a cost and availability issue, as you know, with DOE.
Right.
And by the time they finish with it, we're going to be talking about real expensive costs, and we're going on a flat or decreasing budget. Therefore, alternatives, I think, it's wise to look at all the alternatives, not just in power, but of course there are other technologies too, involving autonomy, for example. And also, of course, collaborative efforts with the Office of the Chief Technologist, which is, they're pushing forward a much less expensive option to get into deep space. So I'm wondering, what do you see as the part of the Institute, maybe in terms of rough percentages that could be devoted to this area?
Again, we can go look at some of this. The things that I would look at is some of the stuff that we're focused on understanding, like the volatiles, the makeup of the volatiles, and that kind of couples into like in situ resource generation or building propellants or whatever from where we're going. But I think we got to kind of understand a little bit of what some of the makeup of is, the materials, some of the environment we're going into, and then we can kind of start homing some of the technology in those areas. And we'll try to leverage with OCT and with the technology folks to get the right technologies to allow us to do those things. We've been working with OCT a little bit already, looking at things like propulsion for deep space. And they've been looking pretty hard at solar electric propulsion. We think that has some advantages to us. They've been looking at some solar array technologies that will help power some of those electric propulsion systems. So we're working pretty aggressively with them. How that directly relates into the Institute and how that ties directly to you, I'm not sure exactly where that folds, but we can show you the challenges that OCT is working on and see if you have some role where you can contribute to some of those activities.
Okay, Larry Taylor.
Yes, I'm Larry Taylor from University of Tennessee, and I'm a lunatic from back in the Apollo days. What bothers me most about changing the NLSI is the fact that over the years I've seen this 800-pound gorilla called Mars eating my shorts all the time. They it's expanding and expanding, and by taking away the focus on the moon and throwing in Mars, I'm afraid that we're going to fall by the wayside again. I've been waiting for the return to the moon for quite a few years, and I want to ask you one question. Do you feel, both of you, that going to the moon first is a priority?
Well, Larry, you and I have had, discussions over the years. You probably don't remember, but that, LPSC and other conferences, and so I know you are a true lunatic, and I appreciate that. And the reason why we had so many astronauts at LPSC year after year is because, we thought that's where we would be going next. And for better or for worse, I'll just give my answer. For better or for worse, the choice of destinations is not necessarily just up to the community or to NASA. It's a broader set of stakeholders, and so I would say that the going to the moon as the next step on a path to exploration is certainly not ruled out. It's not a current emphasis for this administration. And so by expanding the role of the Lunar Science Institute to, a multi-destination or multi-field spectrum, we're incorporating those elements that, are an agency and administration priority. And if we weren't being responsive, they would find somebody else who is responsive, and I think we'd all be worse off. So I don't want to, I certainly wouldn't exclude the moon. I think, in fact, if anything, because of the discoveries we've made on the moon, with Lunar Reconnaissance Orbiter, with LCROSS, with other observations that we've been able to make, reanalysis of Apollo era data, and folks using the samples that we brought back with increasingly sophisticated analytical equipment back here on Earth, and also because of all the science that NLSI has shown that we could do at the moon cooperatively. That's only increased the value of lunar expeditions in a possible path forward. What we don't have right now is a human exploration blueprint that's got the gold stamp of the administration for where we're going to go next. And all of the work that you will be doing in this expanded institute over the next few years, I'm sure will feed into that, and that's kind of the whole point. So that's my 2 cents, Larry.
And the way I put it is that, I look at, we're going to move humans into the solar system. And then the problem, it appears to me, I've been around for a while as well, once we start talking about destination, then we tend to get into trouble, right? We pick a destination, and one administration, one group likes that particular destination, then we get another group in place, and then they like a different destination, and we stop all that activity and we go move to a different direction. So what I'm trying to do on the human side is, I've got a task to build the Heavy Lift Launch Vehicle, SLS, and I've got a task to build the MPC-V Orion. I don't look at those destination-specific vehicles. Those are really a capability that's going to need to be there to move humans out into the solar system, whether it be to the moon or to a near-Earth asteroid or to Mars. I'm building the systems that I need no matter what the destination is. So in a similar manner, we're asking you to broaden your scope a little bit, not focus on any one destination, but actually look at science that has some application at the moon, has some application in near-Earth asteroids, has some application at Mars. Volatiles, like we discussed, is really intriguing. Are the volatiles uniquely different at the moon than they are potentially at near-Earth asteroids, or are they at Mars uniquely different? How will that affect what we're going to do there? How will that affect how we can use those to generate propellant? Those kind of more generic questions and more capability things, I think, allow us to build a stronger, richer base to build off of. And then when we're a little bit closer where we can say we're X number of years away from some activity and we can add the budget numbers up and somebody doesn't pass out when they see the budget numbers, then maybe we can actually then really talk about a destination and move in that direction. And I think we're going to have to move that way. I think logically the nearer objects are more in our wheelhouse. They're more a little bit easier to get to, but I don't want to get in a posture where we just go to the moon and we're stuck at the moon. That's not where we want to be. I really believe humans need to be in the solar system, and we need to look at it in more of a capability manner. And I think this new institute that we're talking about here has that ability to look at it more holistically than a single destination or single location. But it'll be up to you guys to make this work.
Thank you for those answers. Amy Fagan?
Hi, Amy Fagan. I'm finishing up my graduate work at Notre Dame, and I kind of wanted to put forth a student perspective because we haven't stood up much and said how we are feeling. There's a growing concern, particularly among the student population, that we won't be able to survive as lunar scientists. We got into this field to do lunar science. We love lunar science. We want to stay here. So I guess what my question is, can you address the growing concern of the student population? Do we need to diversify, or can we actually survive as lunar scientists, and when we finish our PhDs, are there going to be any jobs for us? Or are we going to have to diversify into these other fields to be able to stay with NASA and stay in planetary science?
Well, there were several different questions in there, but the first thing is, and this is my advice, it's worked for me, is you should continue to do those things that you love doing. And a few rows in front of you, Larry at University of Tennessee has been studying the moon his entire career. Probably got his start in the Apollo program as we started funding the Apollo science, and it served him well. There's no doubt that there's a lot of interest internationally and in the United States to continue to study the moon. Some of my earliest memories, I know this isn't necessarily relevant, but it is for me. Some of my earliest memories as 2.5, 3 years old, is sitting and staring at the moon. It just fascinated me enough that I made it part of my life's desire to go there. And I'm disappointed I'm not going to go to the moon as an active astronaut. And so that's pretty much off the table. We were told when we were hired in 1992, 14th group of astronauts, that we were the astronauts that would go to the moon, and then some of us maybe onto Mars, as was the class before us and the class before that, and for 3 classes after us. I think that, in fact, this astronaut class, that we're interviewing or in the process of selecting right now is the first one where Administrator Charlie Bolden said, and you may go to the moon and help those future astronauts who may go to Mars. In every other class we've said, and you're the ones that will go to Mars, because it's just not realistic. And we were naive enough to buy it hook, line, and sinker because we love what we were doing. And so as long as you love the science you're doing, I think there's going to be a place for lunar science, in the future, and that we will have missions and follow-on missions, and there'll be competitive opportunities for missions that include the moon. And you're young enough that you could go to the moon if you want to be an astronaut and be a geologist on the moon. However, my personal scientific perspective of the moon is in the context of, a feature-rich solar system that now actually is solar systems. We're entering an era where we're, able to study planets and moons in a comparative context with exoplanets that's only going to continue to increase in diversity, that will probably, in 15 or 20 years, include the study of moons around gas giants around nearby stars, and do spectroscopy of those planets at any rate. So I think the field actually is getting more exciting from the general planetary science perspective, and diversity is a good thing. But that's not suggesting broadening your studies because it's a safe bet. You should study what you feel is the most interesting to you, be really good at it, and there'll be opportunities.
And I would agree with that. I think you got to follow your passion, the thing that really gets you excited. There's a lot of interest in the moon. We see a lot of activity internationally. A lot of the Japanese are talking about some landers. The Europeans talk about some landers. There's talk about some sample return potentially from the moon. Japanese with Selene 2. There's a lot of interest there, and it'll ebb and flow throughout your career. Things will move in, things will move out. But if you ought to be following a thing that's passionate to you, and you'll be at the right time when the wave comes in, and then the interest will be in that particular area that you just happen to be aligned with. There may be times when it's not so great, but then there's times when it gets better. So I think you can't guess where things are going to go in the future, but I think you just need to really follow your passion and something that you're really excited about, and that's what needs to drive you and motivate you. And you can find ways to stay pretty excited and employed and still survive in that endeavor if it's something that you're really interested in.
Great. Thanks for the question and answers. Bill Botke.
Okay. I have a lot of questions, and I can't ask them all in this time. But let me ask one particular one, which I think is less political. In terms of near-Earth objects, in terms of the new institute, near-Earth objects are all essentially debris from the asteroid belt or from the trans-Neptunian region. So they're all coming from somewhere else. So if you're going to understand the scientific context of these small bodies, and understand anything about them scientifically, you have to understand the main asteroid belt, you have to understand the trans-Neptunian populations. Are they also going to be included as part of this science institute? Are we going to be able to do searches on that in the context of understanding near-Earth objects?
It's addressed in the can.
The answer is yes.
Yeah, I mean, it's, you know, I mean, that's, it's a good question, and the answer is yes. But we have, a broad array of methodologies for studying that. I mean, not the least, we have, trying to remember the scientist's name at UCLA, has been doing, well, lots of people have been using Hubble, to study main asteroid belt objects and interactions. It's not a static, as you guys know better than I do, but, there are collisions, there are interactions, there are actually hiding, dormant comets that hide there. So if you want to understand the scientific context, the answer is yes, you have to study, both origins and the things that are accessible to us in the near term. But it's not necessarily true that will all be, contained in the cooperative agreement for the expanded institute. NASA has, a $5 billion science program, significant fraction of which between astrophysics and planetary science is to study these regions competitively through selections.
That doesn't really make sense to me, though. How can you have a science institute to study the origin of near-Earth objects and not actually understand where they come from?
I'm saying that it is included, I'm saying it is included, but it's actually much broader than the institute's charter. It's part of our core business in science mission.
But I'm asking just about the cooperative agreement right now that's going to come out. Are they included?
Yeah, it's addressed in the can. They'll have a chance to comment.
Yeah, it's addressed in the cooperative agreement.
And again, I think part of the reason we were going to release the draft cooperative agreement was to get comments like that to fill out those areas that need to be expanded. We've got some words in there now in the draft version. You'll see them. You'll get a chance to comment on them and expand it so we can actually do something that makes sense.
Okay.
Clive Neal.
Yeah, Clive Neal from University of Notre Dame. I just want to thank you two, hi John. I want to thank you two guys for actually talking to us today, trying to allay some worries and fears. And I want to ask a little bit about the term you've used of expansion. Expansion to me means you're going to build upon something you've already got. You've got 7 teams of focused on lunar science, very cohesive, made tremendous progress in science, lunar science, and actually making some of the major discoveries. Also, as part of that, for exploration, some of those discoveries are going to help address the strategic knowledge gaps that are going to be critical to human exploration. So the term expansion means to add to, in my point. So are we going to add new teams to the 7 that we already have? Because the 7 you already have rebuilt the lunar science community, the next generation. And if that suddenly starts to shrink, and that's some of the concerns from the younger generation and the students here, is that as that starts to shrink, the opportunities to be for lunar science tend to shrink with it. So I'm hoping that we can build upon this fantastic start that has been focused through the NLSI, that has created the next generation, that has allowed some of these strategic knowledge gap questions to be answered, and would then allow, because we see with the international partners, are basically focused on the moon rather than going to asteroids and elsewhere in the near future, in the next 10 to 15 years. And so I don't want to see my adopted country get left behind because of that. I would hope that lunar science would be a core that we would continue to build on this, and I would like to get both you chaps' perspectives on that.
Yeah, it's,
Not Mike Largo, not White.
The can will be for 7 new teams approximately to replace the teams that are there as well right now. And then in about 2 to 3 years, we'll compete for an additional 3 to 4 teams.
yeah, and there's nobody that's better prepared to provide good proposals than the guys.
We
that
can
have been-
hear you guys.
Thanks for your answers, John, but your lips didn't move.
This is the way it should be. You know, I mean, do you have control of the camera, or do we?
I think it's your camera on that side.
Okay, do we want to swing around and let you guys answer?
These guys can answer directly. I mean,
Yeah.
You can start.
Sure.
Can you swing it around for us?
I'm not sure we can move the camera.
It's a robotic control question.
Yeah. But you guys will probably recognize the voice.
Why don't you just change seats?
Well, we can speak, and John and Gross can just kind of mouth it.
Yeah.
We're looking at an exit door. What does that mean?
I don't know.
Well, one thing that we can say is that the questions that you guys have been asking are the same questions that we asked ourselves as we developed the cooperative agreement notice that you're going to get a draft of in the near future. And part of adding to the breadth of objects or destinations or targets or whatever you want to call it requires within a constrained budget that we have an additional level of focus. And what you'll see in the cooperative agreement notice is we provide encouragement for how to do that. And with respect to the teams that are already being supported, those guys have, if anything, a leg up in that they have been able over the last few years to conduct outstanding lunar science, and they'll be able to look at how that can be leveraged, extended, and applied to the new directions that the new institute will be going in the cooperative agreement notice. I think you'll see information in there that's going to be looking familiar to you, as well as give you some great ideas as to how to write a great proposal.
There's just a lot of concern with regards to the loss of the next generation in terms of lunar science, Mike, and I know you're aware of this. And so the additional level of focus has been interpreted to being a little bit more defocus in terms of an institute. What is the focus going to be? It's not destination, it's science, but when you start putting diverse science destinations in there, that could end up causing a bit of a defocus rather than a focus.
Well, but I think what you'll find, Clive, is that as you look for those synergies in science across the various targets or destinations, and as you look at those sweet spots that the current teams have already identified of being able to support both exploration and human exploration, that provides the focus, even though you have a diversity of targets.
And for those of you
with respect,
I'm sorry, for those of you who do not know, I want to introduce Bobby Fogel, who's sitting behind Mike. He is our program scientist for the NASA Lunar Science Institute in the Science Mission Directorate. Sorry to interrupt you, Mike.
oh, there was only one other comment that I wanted to make with respect to the students. And that is that this is really an outstanding opportunity for students in that they can maintain an element of lunar science focus but they will enrich their toolbox, if you will, by working with other students and other scientists across the other destinations, and that's going to make them better lunar scientists. Carly, it looks like you have a question.
Oh, hi. Okay. Okay, should I go ahead?
Well, I'd like to bring this episode back to John and Gerst. This was our time with them, so as much as we'd love to hear from Bobby and Mike, I think the main point of the audience here, they would really like to hear from John and Gerst. So if we could get everybody involved in this and not just make it about Mike and Bobby, I think that'd be good.
Well, Gerst and I are okay with that.
Yeah, right. Whatever works.
So you want to go left? I'll drive it back.
This is pretty good. We got John driving the camera here, so this is a good.
Maybe if you guys all sat together, it would be easier.
No, we need to. This is the engineer in us. We have to make this difficult to see if we can learn to operate cameras.
And there's a big robot arm underneath him.
Oops, we lost John.
John's coming back. He was operating the camera.
Yeah, I'm a trained robotics operator. Hi, Carly.
My turn?
Yeah.
Let's see if I can recall where we were now. Coming back to what I presume is going to be in the title of what this institute is going to be called, namely the word science. I'm assuming something like that will be there. But one of the things that this meeting and for the last several meetings has really been a joy to participate in has been the broad interdisciplinary nature of it. Not just science, engineering, you know, all the things that you are hoping for and we want to help you with. One of the things, though, that was a natural progression and which was clearly evident in this year's meeting is the natural link between the moon and small bodies. Many of the talks, many of the discussion here really pointed to that obvious integration of science, the challenges, the regolith, the bombardment, all these issues are very tightly interwoven. And we recognize that and we support it. It's the Mars end that just doesn't seem to fit right. And I think that's where people are worried that we've got such a wonderful momentum. We are progressing in the directions that you've identified, but we just are uncomfortable with what we're hearing. I guess the question is the science going to be in the name? And is there any way we can understand what the relative emphasis on these destinations that you've been talking about?
Well, since we haven't picked a name, I think science should be in the name, and the candidates we've been playing with, science is clearly in there. The challenge in the naming has been the diversity. We don't want a name that's so wide open, that it's not clear what it's for. NASA Lunar Science Institute was pretty specific, and it's easy to understand. As far as having, bring the big dog into the discussion, that is a challenge. And I assume when you said, lunar science and then, minor bodies, you were talking about Pluto and its its moon system? No, sorry. We're talking near-Earth asteroids, not other minor bodies. Good. I'm glad you laughed. Thank you. It was a weak joke at best. But this is this will be something we'll have to clarify is the relative prioritization. Smaller than it was in FY12, but we don't want that to dominate. It really is, as you heard, the whole point is that as we start developing, well, in the current Mars exploration program now, we have the opportunity to cooperate with human exploration and to search for synergies. And what we're trying to do is to increase that cooperation, to look for more opportunities where, the technology to go explore Mars is something that's a technology applicable to future human exploration. And I'm not shy at all when I say, one of the reasons why I think our Mars exploration program is so important and the human component, is to try and get geologists and astrobiologists to the surface of Mars. That's what drives me. That's a long-term thing. And so the kind of things that you've been studying about how what kind of interesting things to do on the lunar surface and how we would use astronauts on the lunar surface, which hopefully are scientists and engineers on the lunar surface. We'd like you to engage the same intellectual enthusiasm for near-Earth objects and for Mars, for how we would do that.
Okay, any other comments? Another question? I see one on this side. Is there no one on this side? Hang on 1 second with you. You go ahead first, John.
Me again, John. Can I go back to a historical analogy on this Moon versus Mars business? You talked to Jim Green. He loves history. So do I. Are we in a situation where the Moon can now be regarded within the economic sphere of the U.S. and the world, and Mars is sort of the frontier of exploration? Is that the way to think about where we're going? With all the stuff with Google X, and we have a lot of ways of getting to the Moon now. It's really an economically viable destination for a lot of things.
I must have slept late this morning because I missed all those ways to get to the Moon. But no, your enthusiasm is, I think, is well taken, and the fact that we have Google X Prize and competitions and people working on landers, and I think it's just a sign that how far we've progressed as a society, that it's acceptable to have those discussions and to put private money and corporate money behind those endeavors that are outside of government investments. Not to say that we're not completely independent, but I would say it's probably a little preliminary to call the Moon part of the the Earth economic zone, in the same way that we don't yet have, and hopefully it'll be a while, if ever, Antarctica is not part of the U.S. or any international economic zone. It's still a research zone. So I'm a little wary of saying that. Eventually, I think there will be a Lunar Oxygen Corporation and things like that, but we're not quite there yet. Are you folks still there? Okay.
Still there. We lost the video, and I would say the same thing. I don't think it's as easy as you described, and there's that bifurcation between the two. I think, I might say we're getting better in low Earth orbit, where we started to open low Earth orbit up to more commercial companies. As you see, the cargo deliveries just starting with SpaceX. Orbital will potentially carry cargo to ISS later this year in a demonstration flight. But that's still beginning, and that still is not really established yet. But that's starting to come online in low Earth orbit. I think the International Space Station has shown that we can keep a human presence in low Earth orbit for an extended period of time, 11 years internationally, which is starting to open that region up. But I think to say we can go much beyond low Earth orbit repeatably and reliably with humans, or to land humans on another body, I think there's still a lot of work to get that to where you described it. The Moon is clearly easier from a delta velocity time constraint standpoint, exposure time, but it's still not readily acceptable or easy within the technologies that we've got today. And can we get some more technology that helps improve that and makes it more routine like you described it? That's one thing we need to start thinking about. We also need to start thinking about breaking our tie with the Earth. I'm a big proponent of the in situ resource kind of stuff, where we can start using some of the materials at these destinations so we don't have to carry everything with us. If we're in this mode where we have to carry everything with us to every destination we go, it's really going to be cumbersome to us to go stockpile and then move forward. We've got to figure out what's available on the Moon that we can use, what's potentially available in asteroids we can use, what's available on Mars to help with the return flight or help with ascent in it. How can we effectively use that? We also, when we went to the Moon, we had a lot of lunar dust, which you're familiar with, right? Now that we look at that, did we really handle that the right way? What we did with lunar dust and that environment was acceptable for a one-time kind of thing in the lunar, when we did the Apollo programs. But if we're going to go there more extensively, we've got to figure out how to deal with these things. How do we do with static buildup? How do we do with cleaning? How do we do, all these things are going to have to get work. So I think there's a lot of challenges in front of us. And the beauty of really your organization is you can bring the scientists to this problem with their desire for that pure science aspect, and then you can bring the engineer, explorer side that doesn't really care so much about the science but just wants to get it done. And you can marry those two together in a combination that actually builds a force that can actually move forward our ability to explore. You know, I would like to design new machines, but if I don't know the environment I'm going to very well, it's tough to design new machines. So we need that scientist, and we need that drive from both of us. In your organization, I don't think there's any better that it really combined the science and exploration aspects together in one organization. You need to keep that strength as we give you a new task beyond just the lunar task to go do.
And can I ask oh, I'm sorry. Do you have time?
Let me just share one.
Do you have time for 3 more questions? We have 3 more questions.
Let me make one really out of the blue comment, but we've been talking a lot about exploration and lunar exploration, near-Earth asteroids, Mars, and the hazards that we'll encounter, and how do we talk about risk. And I was this morning thinking, I happen to have a moon globe in my office, and I was thinking about our Apollo sorties, and by any measure, incredibly successful, and especially 15, 16, and 17 from a science perspective, and the samples we brought back. If we had done a lunar sample return and brought back samples of dust, in today's environment, we never would have sent people to the moon. We would have said, oh no, we need much more study and analysis and mitigation and tox controls before we're going to let astronauts breathe broken volcanic glass. And yet we did it, and it was very successful. So anyway, I know that's a random comment, but it's just something I was thinking about as we think about the risk of astronauts going out to new destinations or back to the moon.
Interesting point. What I want to ask is, do you guys have time for at least 3 more questions? We have 2 microphones already out, and I see 1 more question in the audience at least, but I know we're also over time. I want to make sure that I'm respectful of your time.
Yeah, about 3 or 4 more minutes for me.
Yeah, I've probably got about 3 minutes.
Okay, if you guys could make your questions quick then.
Right. John, one of the terms that you used, Bill, earlier was capabilities. And I think one of the strengths of the Lunar Science Institute and of the LEAG process is mapping out strategic knowledge gaps and then looking at what are the capabilities in a specific way. There's also a financial problem, and I think that you've done some things in commercial crew and cargo to bring private capital investment to develop capabilities. And you already have an innovative lunar data demonstration way of purchasing services. And so I would hope that you could focus on capabilities, many of which we're highly aware of, are more than just the moon, covering these other things, and make the technology investments, and also bring the private sector so that the resource constraints that you're facing are also assisted by people who want to go out and assay the asteroids and develop fuel on the moon. Those people are there, and they're looking for investment opportunities. So I think that's the challenge I see for both divisions, as well as the way in which you're proceeding.
I would just applaud what you just said. I totally agree with what you're doing. In the old world, it needed to be the government doing the entire function. It's clear now there's a lot of interest, and there's spare capital out there, and there's some pure science interest in the broader investment community that's willing to look at some of these things. So if we can figure out ways to put together ways for people to partner with us to bring in other capital, that's a great thing. The other thing we're doing a lot of in the human exploration area is a lot of crowdsourcing and using folks to go do research for us. We put some databases out there and have people actually analyze the data for us in their spare time, and that's been pretty productive for us in some of our other activities. So we need to collectively all keep working the way we can leverage the larger community of folks to see and get excited about what we're doing.
Okay, next question.
John, this is Buck Sharpton from LPI. I had the pleasure of attending the Mars Concepts meeting a few weeks back that you helped organize, and that really looks like that human exploration and planetary exploration are moving along the parallel tracks now for Mars. Just as an alternative vision, why not think about taking this wonderful lesson that we've learned from NLSI and applying it to the Mars exploration program and having a separate, you can call it an institute if you will, but a separate focus, and then having the upcoming CAN language that encourages the NLSI or whatever it's going to be with small bodies to interact productively with the Mars program. And that way, there's a balance there that I think makes sense, and we can expand teams based on the same kind of cooperative approach that we use with our international programs, if you will, that if you're part of the Mars community, you get your resources from the Mars exploration program. If you're part of the lunar sciences or near-Earth asteroid community, then you get your resources from the new NLSI.
Well, we had the discussion of should we, keep the NLSI identity as it is and start a, NEO or NIA Science Institute and a Mars Science Institute to do them separately. And, the other than the funding issues and, how do we spool them up, the consensus was, that the NLSI has worked so well that we should leverage it rather than try and duplicate it. I think that was the gist of the discussion. So the recommendation that came to us was to expand the role, and I think that'll enable synergies and the interdisciplinary nature of all of the activities where there's commonality to a much greater degree than it would to have semi-independent organizations with joint meetings or something like that. To really force it down to the team level.
Okay, Jack Burns, last question.
Hi guys, Jack Burns, University of Colorado. John, you mentioned earlier about coronal mass ejections as an important hazard, and there's a lot about these objects we don't understand yet, and using low-frequency radio telescopes, for example, to, for the first time, image these objects and understand how they accelerate particles is pretty important, along with similar low-frequency telescopes on the far side that I know you're familiar with to be able to study the cosmic dawn is pretty fundamental. And then things like lunar laser ranging to the moon and then eventually to the moons of Mars to constrain general relativity as well as the coordinate systems in the solar system. I think some of the things that our team and others have been doing has demonstrated the viability and how that adds in important ways to human exploration. So the question is, with this new revamped institute, are the broader space sciences, namely heliophysics, astrophysics, in addition to planetary science, going to be welcomed in this new program?
Well, they were certainly welcome in the first call, and I don't think we're thinking of excluding anything. It really is an expansion. It's not just lunar science, but also the use of the moon or other destinations to enable science. I'm looking to my team.
Go ahead, Bobby.
Bobby's going to jump in too. So actually, I'm told it does not include that right now. So that's a discussion we'll have to have in your feedback when we put the community announcement out. Is more than welcome, in fact, required.
No, I think a lot of the questions today, you ought to take a good look at this draft CAN we put out. Think about it in light of the discussion we had today, and really give us some quality comments back on that draft cooperative agreement notice. And because we were pretty open. I mean, these guys have done a tremendous job of getting together.